Today we will solve the problem 4.48 of Griffith third edition Introduction to Quantum Mechanics. The problem 4.48 consists of three parts. Part 1 is prove the three-dimensional Virial Theorem is 2 times the expectation value of kinetic energy is equal to R dot gradient V. For a stationary state, that is very important. So you take a time derivative of R dot P. Here you can see this R dot gradient V. What is momentum operator? Momentum operator by definition is minus I h cross delta over delta x. So this is delta over delta x is nothing but the gradient in one dimension. In three dimension, it is equal to gradient gradient. That is in three dimension. It is the momentum operator is I h cross gradient. So we have taken this derivative of R dot P, time derivative of expectation value of R dot P, which is equal to I over H cross the uh, expectation value of commutation of H with R dot P. This we have seen in the case of the Schrodinger picture. So here we have ignored the partial time derivative of the operator because there is no explicit time dependence in this operator. This can be written as the time derivative of expectation value of R dot P is equal to 1 over H cross. This I am taking the P right hand side P to the right hand side and the left hand side R to the left hand side. So commutation of H with R multiplied by P plus R multiplied by the commutation of P H Hamiltonian with P. So this can be written as 1 over I H cross Hamiltonian by definition is equal to P squared over 2m plus V. So I have replaced this H by P squared over 2m plus V. So now you know V and R will commute in the first term. So that will be equal to 0 commutation. So only non-commuting term is P squared and R. So you take 1 over 2m outside, then this will become commutation of P squared with R. Of course, you have to multiply with P. Then here P will commit with P squared will commit with P. So that will become 0. Only non-commuting term is V and V with P. So we have replaced this time derivative like this. We will reduce it further. So we have seen the time derivative of expectation value of R dot P is equal to this one. Now you take the first commutator relation. That is 1 over 2m, 1 over 2m, the commutation of P squared with R. Of course, we have P outside multiplication factor that we will take care at the end. This commutator 1 over 2m P squared with R can be written as 1 over 2m. This P can be taken as P into P. So this left hand side P is taken to the left hand side of the commutator bracket and the right hand side is taken to the right hand side of the commutator bracket according to commutation rule. So this can be written as 1 over 2m P squared with R can be written as P commutation of P with R and plus commutation of P with R multiplied by P. So now you know this commutation of P with R is equal to minus I H cross. Same thing is here, minus I H cross. Remember that there is a P outside the commutator. So this will become minus, of course we have 1 over 2m minus 2 I h cross multiplied by this P. So now 2 will get cancelled. You will get simply minus I h cross P over m. Now you take the second commutation. We will multiply later this by r. So you will get the commutator V with P act on some arbitrary function g of r. The commutation relation can be written as Vp minus Pv. So first you take Vp, V I have taken, and P I am replacing by its operator minus I h cross delta G of R over delta R, and next PV. P is minus I h cross, minus of minus will become plus, plus I h cross delta over delta R V multiplied by G, because you have PV, of course you have to multiply with G. Now first term you keep as it is. Second term, UV method, that is you keep V as it is, then differentiate this G. So this will become delta G of R over TR, delta R. Then you keep G as it is. Then this will become I h cross G delta over delta R V. So now you see the first two term. This will get cancelled. This and this will get cancelled. You will get only the third term, and here you remove this G of R, both right hand side and left hand side. So this can be written as commutation of V with P is equal to, you have I h cross delta V over delta R can be written in the 3 dimension. The gradient V, this delta V. So now you replace this and this, replace this commutator relation here. So here first thing you will get I minus I h cross P here, minus I h cross P over M and multiplied by P. Then next one is uh, R times this I h cross I h cross R times this gradient V. So that is delta V you got. Now we will simplify this further. Now we got this relation. Here we can cancel some of the terms, particularly the H cross. H cross will get cancelled with this H cross and this H cross. Then you multiply this term I inside the bracket. So if you bring I inside, you will get I into I is I squared, which is minus 1. Minus of minus will become plus. Remember that there is P outside. So P into P, you will get P squared over M. Then here I into I is equal to I squared, which is minus 1. So minus R dot delta V, which is equal to this first term. What is this first term? P squared over 2m is kinetic energy. This is 2 times the kinetic energy. 2 times the expectation value of kinetic energy minus the expectation value of R dot delta V. Now, for a stationary state, this time derivative will be 0. That means 2 times the expectation value of kinetic energy minus the expectation value of R dot delta V is equal to 0. That is 2 times the kinetic energy is equal to the R times the delta V. So we have proved this relation, part A. So section P is Apply the Virial theorem to the case of hydrogen and show that the expectation value of kinetic energy T is equal to minus E is sub n, that is nth energy state. And also the potential energy, expectation value of the potential energy is equal to 2 times E n sub n. So we know very well that the potential energy for the hydrogen atom is equal to minus 1 over 4 pi epsilon naught 1 over r. Now, if you take a derivative, that is, if you take gradient, that is delta V is equal to, you differentiate this. If you differentiate 1 over r, you will get to minus 1 over r square. Minus of minus will become plus. So, now you multiply this by r dot delta V of r is equal to 1 over 4 pi epsilon naught 1 over r. That means r dot delta V of r is equal to minus Vr. Just this with negative sign. Minus Vr is equal to 1 over 4 pi epsilon naught 1 over r. Then just now we have seen 2 times in section A, 2 times the kinetic energy is equal to the expectation value of r dot delta V. So here r dot delta V is minus V of r. So minus V of r. Then what is the total energy E of n is equal to the kinetic energy plus the potential energy. That is a expectation value of T plus the expectation value of V. So we know this expectation value of V here is equal to minus 2 delta. So this is the expectation. This can be written as minus expectation value of V is 2 times expectation value of kinetic energy, or expectation value of V is equal to, you bring this negative sign to the other side, you will get minus 2 times the expectation value of T, which is equal to minus expectation value of T. Then naturally, what is T? T is equal to En. Here, T is equal to, En is equal to minus expectation value of T. Then the expectation value of T is equal to minus En from this. You can see this is minus En. Then what about expectation value of V? From this we have seen expectation value of V is equal to minus 2 times the expectation value of T, which is equal to minus of minus will become plus. So expectation value of T is equal to minus En. So this will become 2En. So we have proved this relation also. We have proved this. Then we will move on to next. Next, section C is apply the Virial theorem to the three-dimensional harmonic oscillator and show that in this case expectation value of T is equal to expectation value of V, which is equal to E sub n over 2. Now in the case of harmonic oscillator, the potential energy is of m omega squared r squared. In the case of one dimension, it is x squared. Because it is three dimension, it is r squared. If you take the derivative of this, if you differentiate r squared, you will get 2r. 2 will get cancelled, so you will get m omega squared r. If you multiply this by r, that is r dot delta V is equal to m omega squared r squared. So this is literally equal to 2 times the potential energy. 2 times the potential energy. So we have seen in section A, 2 times the kinetic energy is equal to r dot delta V. That is 2 times the potential energy is equal to 2 times the kinetic energy is equal to uh, 2 times the potential energy using this relation, because R dot delta V is equal to 2V. That means 2 times kinetic energy is equal to 2 times potential energy. 2 will get cancelled. You will get the expectation value of kinetic energy is equal to expectation value of potential energy in the case of harmonic oscillator, as expected, because harmonic oscillator is a symmetrical one. So E sub n is equal to T expectation value of T plus V. So here in our case T is equal to V. Naturally this will be equal to En divided by 2. We have proved this also. So thank you very much for watching my videos and supporting me continuously. Thank you very much.